A famous ancient Greek philosopher called Archimedes was the one that found out the world by making measurements. One of the best examples of his measurements in his study is lever. Here we are going to talk about the law that Archimedes discovered and the examples of the three types of levers.
The turning effect of a force is known as the moment. It is the product of the force multiplied by the perpendicular distance from the line of actions of the force to the pivot or point where the object will turn. It is composed of two arms and a fulcrum, or you can say the pivot. The force applied to the lever to do the work is called the effort. It opposes the force that is resisting the movement called the load. We normally see this in a childhood playground, which is the seesaw. If both sides of the seesaw are balanced, the moments are opposite and equal. Then we have the wheelbarrow. We used to see builders carrying wheelbarrow to carry heavy things like stones, or can be gardener carrying soil. If the effort to lift the wheelbarrow is enough, the wheelbarrow won't stay on the ground and you can't push it. And lastly, we have the broom. If the effort given by the broom is enough, it will lift the broom, since the end of the broom is the output force.
Turning on a pivot. Types of levers. There are three different types of levers: first class, second class, and third class. A first class lever contains the effort on the right, load on the left, and fulcrum in the middle. A second class lever contains the effort on the right, fulcrum on the left, and load in the middle. Finally, a third class lever contains the load on the left, fulcrum on the right, and effort in the middle. Examples of each of the following levers are first class being a seesaw, having effort on the right, load on the left, and fulcrum in the middle. A second class lever being a wheelbarrow, having the effort on the right, fulcrum on the left, and load in the middle. And finally, a third class lever being a broom, having the fulcrum on the right, load on the left, and effort in the middle. So, what are their functions in our daily lives? Well, for a first class lever, it is able to change the direction of where the load is heading towards. For a second class lever, it is able to make the load gain more force than usual. And finally, a third class lever is able to make the load gain more speed from less force.
Moments. Moment of the force is the turning effect produced by a force around a fulcrum. The moment is found by multiplying the size of the force by the distance between the point at which the force acts and the fulcrum. Formula. The formula of moment is force times distance of the fulcrum. It is measured in Newton meters. For example, the force of the blue block is 4 Newton and the distance between the fulcrum is 20 meters. Then it will be 4 times 20 equals to 80 Newton meters. As you can see, the left side and the right side is different. The left seesaw is balanced while the right side is not. It is because the left side's one both distance from the fulcrum and the force is the same, while at the right side the force is the same, but the distance is different. The left one is further than the right one.
The principles of moments. The principles of moments says that if an object is in balance, then the anti-clockwise moments is equal to the clockwise moments about any chosen pivot. Moment equals to the force times perpendicular distance from the line of action of the forces to the pivot. For example, we have a uniform rod AB of weight 100 Newton and length 2 meter. Is supported by two vertical strings at its ends and carries a load of 20 kg as shown in the diagram below. Determine the tensions in the strings. First, we take the moments at A. 100 times 1 plus 200 times 0.5 is equals to T2 times 2. T2 is equals to 100 Newton. The sum of upward forces is equals to the sum of downward forces. So T1 plus T2 is equals to 200 plus 100. T1 is equals to 300 minus 100, which is equals to 200 Newton. Or we can take the moments at B. 100 Newton times 1 plus 200 Newton times 1.5, which is equals to T1 times 2, and then it is equal to T1 equals to 200 Newton.